Welcome to Steam Powered, where I have conversations with women in STEAM to learn a little bit about what they do and who they are. I'm your host, Michele. My guest today is Dr. Shelly Lesher. Shelly is an experimental nuclear physicist who is passionate about dispelling misconceptions about nuclear science and explores the relationship between nuclear science and society. She also hosts a podcast, My Nuclear Life, where she delves into these themes through interviews with experts, historians, policymakers, and first-hand accounts. Join us as we talk about nuclear physics, how nuclear sciences impacts our world, and Shelly's love of shoes. Welcome, Shelly. Thank you so much for joining me on Steam Powered. It is wonderful to have you on.
Thank you for having me. It's my pleasure.
So good to finally get to speak to you, especially after we met online. That's great. So you mentioned you had an interesting origin story, and you're currently in nuclear physics, but that's not where you started.
Yeah, so it is kind of interesting. The students always think that you have to have known you wanted to do physics since you were small. And I grew up not thinking that. I grew up thinking I was going to be a lawyer. I was going to go into politics. That was what I thought I was going to do. My whole family thought I was going to go to law school. And when I got to university, I started taking political science classes. But as part of, in the US, we have what's called general education. So if you do whatever subject you do, you have to take this core of classes around it in a whole lot of different subjects. And so I decided that, well, astronomy sounded like fun. So I had to take a science class, so I took astronomy. And that was really interesting to me. And so I thought, well, I have to take two science classes. So I really liked the professor. So then I took physics with him. And, I kept taking political science classes. And when I talked to the physics instructor, I was just talking to him about how I really wanted to go out to Washington, D.C. in the summer because political science, you want to be in Washington. And he thought, well, I have this project that I need done in DC, so why don't I send you out there to do this project for me? So as a freshman, I'm 18, I get sent out by an astronomer to go work at the Goddard Space Flight Center in DC to do this astrophysics project. And I decided that I didn't like astronomy. I didn't like astrophysics, but I wanted to keep taking physics classes because it was really interesting to me. And so I got back and he sent me to work with a wonderful woman named Ani Abrahamian at the University of Notre Dame that was just down the street from where I went. And I just kept taking physics classes and kept doing physics research. And one day he just said to me, you have to change your major. Like, you're not a political science major. So I did land up graduating in physics with a minor in political science and math. So, and didn't become a lawyer.
Completely different.
Completely different, yeah.
They tried to introduce what they called the common first year, which was meant to reflect that general year at college in the US. And I always thought that was such an interesting idea because you could do things like philosophy, you could do things like astronomy and just kind of explore all these different options. And when they offered that option to us in the sciences, I don't know whether they tried to do this in the other departments, the common first year was just, well, if you're an engineer and you're doing computing, then your common first year is going to involve computing and a couple of engineering basic units and stuff like that. But that's not very broad. That's still very narrow. And I couldn't see how that would be useful. I mean, it was not for my year. That was I was tutoring at the time they started doing this. And it was very badly received, unsurprisingly.
I can imagine.
So a lot of the students who were doing engineering was like, why do I have to bother with computer science? It's not important. And it's like, well, you're still going to have to do some of this at some point. Like, just because, it's not your major, it's not that you're not ever going to have to touch any of this stuff. But, it would have been so interesting to get to do all these other broader range of subjects and just get a little bit more roundedness to what you do at uni.
Yeah, and that's the idea now. there's arguments on how much you need to do. So some universities have a really, really big program, like ours has a very big program, which I personally think it could be a little bit smaller. Others have programs that are much smaller. They're done in many, many different ways. But,
Yeah.
I think it's important for, especially for science students. I mean, of course, I think everyone should have science, obviously.
Yeah.
Um, but I think, as you were saying about computer scientists needing or engineers needing, computer science or, something else, I think it's important for scientists to understand how their work impacts the world.
Exactly.
And
Yeah.
you don't get that just from hard science classes. And that's really been, I'm jumping ahead here, I'm sure, but, you know, that's really been the focus of my work the last maybe 5 or 6 years, which is kind of combining that love that I had for political science and kind of that interest that growing up, I always had an interest in history, those interests in humanities, and bringing that in with science. So saying, you know, as a physicist, you don't think that, you know, history and literature and political science is important to you and impacts you. But if I can show you how to make all of those connections, then you'll start seeing the world in a different way and seeing that what you do in science impacts the world and the world impacts
Yes.
science. Like we're all connected and you can't just learn one thing. You have to see how it intertwines.
Exactly. That is precisely, why I'm doing the whole STEAM thing, because so many aspects of the arts bleeds into the sciences. It's, you just can't avoid it. And all the way through history, that's been the case.
Exactly.
And a lot of people forget that, we impact each other in so many different ways. And you don't really see, like, you just even looking at pop culture, right? So all the stuff that we see on TV and the media, they're already influenced by all the sciences. Look at Star Trek, right? Influences both directions. It's crazy that, you forget just the full breadth of impact.
Absolutely. And also that we have a diversity problem in physics, especially com-
Yes.
computer science, physics. Uh, there are not a lot of women in either of those fields, and when you start talking about non-white individuals, there are not a lot of those people represented in those fields either. And research has shown that if you want to attract a more diverse group of individuals to physics or computer science, then you have to show them why they should be there. And it's not just all the
Yes.
people who say, I, since I was young, I stared up at the stars and wondered how the universe came together. Because not everyone has that luxury, right? If you live in
Yeah.
the middle of a city, you can't look up and see the
Can't see
stars,
anything.
right? Not everyone has this education where they had this wonderful science teacher that knew physics or knew computer science and got them involved. Not everyone has that. But everyone has something that they're passionate about, whether it be a social justice issue or something involved in their neighborhood or their community that they want to bring back. And it's our job to show them how computer science and physics and chemistry and biology can be used to help them do what it is that they want to do in their lives. And we have not done that very well in the past. And I think it's our job to do that. And research has shown that when you do that, you can attract a much more diverse group of students to your field once you show them what they can do with the information they get, instead of people thinking,
Yeah.
oh, you do physics, you can be a professor. That's not
Exactly.
everything you can do, or you do computer science. What is your background in computer science or engineering? Or
I did computer science, straight computer science, and then I'm now basically by day a web and application developer. So, yeah, that also wasn't exactly a thing anyway, because web and application development didn't really exist properly when I started university. So that was still emerging kind of as a field. But yeah, definitely a lot of the times, like, oh, I'm going to do computer science. I want to be the next Bill Gates. I want to be the next Steve Jobs. And it's like, well, there's so much more scope than that. It's not just about being, the multi-million billionaire. Like, there's so much other scope to the applications of the work that we do that can, affect everywhere and everything.
Yeah, you can use it to impact your community. You can use it to impact the causes that you're interested in. You can, use those skills to do so much more than just create a company and sell it to some venture cap or, whatever it is that makes you money, right? I mean, if
Yeah,
you want to do that, you can, but you don't have to. You can use those skills and do so many other things. And that's, I think, what you're trying to do here. And what, I'm trying to do is, let students know more about what their options are, and yet let young people know what they can use science for.
exactly. And yeah, that's amazing. And we'll get back to that.
Okay. Yeah.
No, all good. We'll get back to that. Yeah, so you went from political science to physics,
Yes.
decided astrophysics wasn't for you.
No, no.
And so, how did you move towards nuclear physics?
So I was sent to the University of Notre Dame to work with this, as I said, this wonderful woman named Anya Abrahamian. And she had more ideas than she had students. So she was in nuclear physics. She was at the nuclear physics lab, the nuclear structure lab, and she gave me this bunch of ideas, and I chose one that I thought was interesting. And it's actually still it's the project that I've gone back to. I started with it. I did a couple of different things, and now I've moved back to it. So I'll tell you what it is. Um, Nuclei are not all spherical. In fact, most of them are not spherical. Although when you see a picture of a nucleus in your head, you see, this hard center, well, the atom, right? You see this
Yeah,
hard center, and then you see the electrons moving around, and then you just see this hard sphere in the center of the atom that is full of protons and neutrons. And so when you see that image of the atom, you think, oh, the nucleus is in the center and it's just a sphere. And in fact, nuclei are mostly not spherical. In fact, we haven't actually found a perfectly spherical nucleus. So they are more like, well, they take on whatever shape is going to be the most energetically feasible, because they don't want to expend energy by trying to maintain some sort of shape. So whatever the shape is that is going to be um,
most
energetically
efficient.
feasible, most efficient. Exactly. What I look at are nuclei that are called prolate. So in Australia, you'll know they look like a rugby football. So an American football has these like pointed ends, but a rugby football is more rounded.
Yep.
So they look like kind of like oblongs, right? So if you kind of think about like a liquid drop model of a nucleus, so if you take a water balloon and you tie it at the end and then you hold it, and so you can imagine it's got like kind of that teardrop shape and it's full of fluid. So if you start moving it around, it's going to change shape, right? So again, it's not this rigid sphere. It's kind of this movable bag of
Yeah, it's a
water
bit more
almost.
fluid.
Exactly, exactly. So what we're looking at is if you take this rugby football and you start spinning it, and because they're nuclei, they're not going to just obey like, oh, it's here, so we're just going to spin like this, right? It can spin on different axes and
Yep.
do okay. Now, we know they spin. We can definitely see that they spin. The question is, while they're spinning, are they actually vibrating? So are they actually doing this? And are
Oh,
they actually doing this?
that's
That's
cool.
the question. Bohr-Modelson won their Nobel Prize in 1975 for predicting this in in their model. But there has been great debate on if it happens or not. In fact, it was yes, it does. No, it doesn't. Yes, it does. I mean, it's been going on for, I mean, I was born in 1975, so I'm giving away my age. But I'm working on a problem that won the Nobel Prize the year I was born. So nuclear
Yeah.
physics is a very old field that is dealing with very mature, basic problems. So I mean, the more kind of like sexy problems are not the nucleus. It's not the protons and neutrons, right? You got to go in the nucleus. You got to go in the protons and neutrons. You got to go in the quarks, right? So you get further and further and further in until you're looking at, the gluons, you're looking at the Higgs, and now you're looking at, we're not even looking at particles anymore. We're just looking at waves. So that's what people think are like, ooh, sexy and new and Nobel Prize worthy. What I'm doing is not Nobel Prize worthy. It's basic research on what is the shape and structure of the building blocks of matter.
That's cool.
That's why I think it's
That is very cool, though. It is cool because, it is foundational stuff, but it's cool because it's foundational stuff, and it's foundational stuff that we don't know yet. That's
exactly.
awesome.
And what always fascinated me is, how is there a problem that is this old in something that's so foundational and we're still arguing about it? We still have journal articles, like everything in physics or everything in everything goes in cycles, right?
Yes.
So okay, so this is the problem I started working on in undergrad. And sorry, my conversations are not linear.
That's fine. This is cool.
Okay, so I started working with Ani Abrahamian. I knew nothing about nuclear physics. And I'm sure you understand how it is that people learn. But any young people out there, people think that you just get told something once and you suddenly like miraculously understand what's going on. I don't learn that way. I don't expect anyone else to learn that way. And poor Ani had to put up with me. I would ask her a question. So this is how I learned nuclear physics as a sophomore in college, because I had just had modern physics. I just learned what the nucleus was. I just learned what protons and neutrons were. And now I'm like, wait, what? They're not spheres? They're not spheres? Like, what's going on? So I had a question.
I've lived a lie.
Oh, wait until you tell people about the speed of light. That kept me up for a night. And then in grad school, they tell me that it's not a constant after all. And then that was like, it's a whole nother story. So I would go and ask her a question and she'd give me an answer. And I'd say, okay. I'd go back and I'd do some reading and I'd think about it some more. And then I'd come back and I'd ask her pretty much the same question. With a few more details here and there, because I had done some more research. I might have like framed it a different way. And then she'd answer it again, give me more information. And this would go on and on and on until I finally understood the question I was asking. And bless her for being so patient with me. But I mean, that's how you learn. You don't understand it the second someone tells you. You don't like miraculously understand this really complex question because someone tells you the answer once.
Yeah. And also it's about like they'll answer you in a way that suits the frame that you gave it, but at the same time, because you're learning, your frame isn't exactly solid. You're going on what you think you understand from it. So which is why when you went away, did a bit of research, came back, asked the same question but with a bit more context, and you're just continuing to build on that until you finally develop this other structure for the question that you actually needed to ask.
Exactly. And so glad that she understood what I was doing and that she made me feel so comfortable, or I just didn't have any sense of, I don't know, shame, but
Yeah.
that I could come back to her time and time again and ask the same question. I was so comfortable with her. And I
Yes.
really remember that. And I try to do that with my students as well. And I tell them to do that and that I've done that to hopefully they come back over and over. So anyway, I started working with her. I really enjoyed this problem. I felt like I was actually starting to understand something. But one day I was in the lab, and this was at a time where everyone didn't have their own computers. You had computer clusters. I don't know if you remember
Mm-hmm.
those times. And so everybody
Yes.
like hung out in one spot with like 10 computers, and everybody hung out. Anyway, so I couldn't sleep because I wanted to work on my research. And so I got in really early in the morning, and I was working, and I was so engrossed in my problem that by the time I looked up, it like the whole day had passed. I hadn't done anything. It had been like 6 or 7 hours. And, I hadn't gone to lunch. I hadn't gone to the restroom. I hadn't done anything. I had just been so engrossed in what I was doing. And I thought, like I can do this this is what I want to do because I'm so interested in this that I didn't even notice how much time had passed. And isn't that really what you want to do in life?
Yeah. Yeah. Just completely, just so involved in the things. Like, yeah, this is a thing that engages me.
Exactly. So I decided that if I wanted to do research, I had to go to graduate school. I don't like physics classes. Like I didn't enjoy them. I didn't look forward to them. I didn't necessarily have the best grades in any of them. I was an experimentalist. I liked doing experiments. I liked analyzing data. I liked that part. And I was good at that. And that's what got me through graduate school. But I decided that I would keep doing physics and I would keep doing nuclear physics until it wasn't fun anymore. And that was always the kind of test that I had for myself. And I'm just like, okay, I'll go to graduate school. If it's not fun, I can leave. Okay, I'll do a postdoc. If it's not fun, I'll leave. I just keep saying that to myself, and still, like, it's still fun. But if it stops being fun, then I'm going to go do something else. So it just kept being fun. So I just kept doing it.
That's a good way of doing it.
I mean, and I'll tell you, I hated my classes. So the classes weren't fun, but I had the research there. So when I went to graduate school, I started research immediately because this project that I was given, I got a paper out. I got a first author paper before I even
Nice.
graduated. So that got
That's
me into
cool.
grad school, and that got me into doing more research. And so I had that research all through graduate school that kept me motivated. So I'm like, okay, I have to do the classes because I know I can do the research. And so if I hadn't had the research, I probably would have left graduate school
Yeah.
because it just wasn't,
No
the classes
motivation.
weren't, there was no motivation exactly. And the classes weren't fun. And then after that, I wanted to leave the country. I wanted to go to Europe for a postdoc because Ani took me to France for an experiment, and I love to travel. I've always loved to travel, and made me realize that nuclear physics, you can travel all over the world if you
Yeah.
do
It's
nuclear
portable.
physics because there's accelerators all over. And so I went to Belgium. I went to Leuven, Belgium, to do a postdoc. And the majority of my work was done at CERN. So I spent a lot of
Nice.
time at CERN, which I think a lot of people know. It was a time where the US hadn't bought in yet. So there weren't, I think I was the only American in like
Wow.
the part of the building that I was. The super collider wasn't like started up yet. So it was a truly European experience to be at
Wonderful.
CERN during that time. Um,
That's cool.
yeah, it was super cool. Then I did another postdoc at Lawrence Livermore National Lab, which is a weapons lab in the U.S. I didn't do weapons work, but it is one of our weapons lab. Los Alamos is another one. And I decided that it was fine, but it was research only, and it wasn't research. You're kind of told what research to do. You can't really choose your own project. And I wanted to go back and work on the nuclear the nucleus, the vibrational nuclei again. So
Yeah.
and I really missed students. Just students bring so much life, and it keeps you young. And I just felt like it would have, yeah, it's,
Yeah, for you,
yeah.
it just wasn't the right space.
Right. For me, it was not the right space. It is the right space for a lot of people. For me, I need to be in a university. So I landed up coming to the university I'm at. And so I've been here for 12 years. I'm at the University of Wisconsin, La Crosse. And this year I just became full professor. So I'm now like
Nice,
as
congratulations.
high as I can be. Oh, and I just became chair too. So I'm like as high as I can be.
Wonderful.
Yeah.
That's great.
Without being like provost or like something fancy, like some sort of administration fancy.
That's cool. So,
Yeah.
because you wanted to work on the nucleus again, did you have to find a university that was in that space, or did you just like how did you find a place where you could go, I want to study this and this is what I'm going to do?
That's a really good question. I looked at places that were similar to the school that I went to. So in the US, we have different types of universities. There's what's called an R1. It's a research heavy institution, which are all the universities you've heard of. Yale, Harvard, MIT. These all have PhD programs. They all have like millions and millions of dollars of research funding coming in. The professors there just do research. They probably teach maybe one class a semester, maybe one class a year.
Wow.
Yeah. And then they do a lot of work with research with graduate students. They have postdocs, like they have teams of people. That's not what I wanted. I wanted a school like I went to, which was, they're called primarily undergraduate institutions. And there are institutions in between the two that I'm talking about. So at the institution I'm at, you teach more. So instead of teaching one class a semester, I teach 3 classes a semester. And I do do research, but for example, if you're at one of these big research institutions and you don't get funding, then you get fired, right?
Lose tenure. Yeah.
Yeah, that's a big deal. At my institution, if I don't get funding, it's okay. I can still do my research. I just don't get paid in the summer. So it's a different expectation. The expectation, though, is that I work with students in research. Whether it's funded or not is up to me. And
Cool.
that's what I wanted to do. I wanted to work with students, and I wanted to make a difference in students' lives. And I've been lucky in that I have been funded since I've been there. So I have been very successful in getting research grants that fund me and fund my students. And we are able to actually, we go back to the University of Notre Dame in the summer, and we still work with Ani Abrahamian, my undergraduate research advisor. And we work with her every summer, still working on trying to figure out if these rare earth nuclei vibrate. And just got a big grant to build a detector array that my students and I are going to this summer. So they're actually taking us this summer. They lifted some COVID restrictions, so we're going to be able to go.
Excellent.
Yeah, it's really
That's
exciting.
very cool.
Yeah, so I'm taking 3 students with me, and so that's pretty fun.
That's awesome.
Yeah, so that's why I decided to go, because I have a lot more student interaction at the university I'm at, which I really enjoy the interaction.
That's great. And yeah, because it is, more focus on the students. Yeah, obviously that gives you the flexibility to choose what area of research you want to pursue, because it's
Absolutely.
optional whether you actually get the funding so you can pursue that. That's cool.
Yeah.
So with the, I guess, with the, okay, we're not going to go into great detail about this, obviously, but with the vibrations, is what's been preventing people from having a solid answer just because we don't have the technology to figure it out yet?
You're on the right track. One of the reasons physics goes in cycles is because, when the problem was first introduced, we had the theory and we had some experimental apparatus and we had some computational abilities, but those were limited. And then they kind of went as far as they could. And then it cycled back around because now we have better detectors, we have better computational abilities, but then it hit a standstill again because, we couldn't push it any further. And that's one of the reasons we're building this new array, is because now we figured out a new way to kind of probe a different way. And so we're building a new detector. And so this is one of the things I really like about nuclear physics, is that you can look at a paper from decades ago and you can improve upon it. And maybe their conclusion was wrong. Maybe they didn't have great resolution. But you can still use it as kind of a basis to a touchstone to go off of. I mean, there might be one or two things wrong, but you're not going to go back to a paper from 5 years ago and go, oh, that's completely wrong. Like you do in astronomy. I mean, in astronomy, a 5-year-old paper can be completely out of date and just be like trash. And so it's like, I have no idea in astronomy what paper I should believe and what paper I can't. But in nuclear, sorry, it's my dog.
That's okay.
In nuclear, you can you have this really nice timeline of, and you can see this exactly. You can see this timeline of when technology and computing power gets better, and then there's this, like, you get a massive experimental data, and then you get tons of theory that comes out because all the theorists are like, oh, let me try to explain everything you just saw. And then there's kind of a lull, and then we get better with technology, and then big burst comes out, and then there's this more. So, one of the reasons we haven't seen it is because what we're trying to find is very difficult. We're trying to look at a vibration that, when you see it, is doing this.
Yeah.
Okay, so see how hard that is to observe.
It's very subtle, especially when you're looking at the scale as well.
So it's a very subtle vibration. We have seen this one. So you can see this one is a very...
It's more distinct.
Thank you. It's a very distinct vibration. The other one is very subtle, and there is great debate over what conclusively tells you it exists and what doesn't. The original theory doesn't actually say what they think, doesn't give numbers. So that's where the great debate is. And then, of course, if it's not that, then what are these anomalies that we're seeing? If it's not, what we call a vibration, then
what are you observing?
What are you observing? Because you're observing something. And then, of course, everything vibrates. So why aren't nuclei vibrating then?
Logically, it should.
It should. So, to me, this is a fundamental question that we still don't understand. And so that's why I think it's fun to look at it.
That is very cool. Yeah, I can see how that really engages you. Yeah, so much subtlety in what you can observe and develop from that. And that's very interesting. Just adding more confirmation to what we already know. It's very cool.
Yeah.
So, so that was your research part. Now, your teaching part is, again, we'll get back to this, the effect of nuclear science in society and how it really does impact us.
Right.
So, you've already mentioned that this is interesting to you because of the importance of being able to understand the context of what we do and how it affects everyone else. So when you designed this course, what did you have in mind for, your objectives? Because these are already students who are in nuclear science, or is this part of the general first year?
Yeah, so it's part of this general education curriculum. And what I envisioned this class to be did not turn out to what this class actually became. And my podcast has kind of turned out to be what I thought this class should have been. So, what I wanted the class to be was to teach kind of a general public why they shouldn't be scared of nuclear physics. But that's not how it turned out. How, how it turned out was everyone not in physics was scared to take a physics class, even if it had no prerequisites. And even though it says like no math, no prereqs, like counts as like it doesn't matter. So nobody outside of physics wanted to take it.
So you're preaching to the choir at this point.
Right. So then it turned out to be, okay, it's basically now physics students, but they need this gen ed. It's called like global society. So now I have to say, okay, I have to now show these physics students how nuclear science impacts the global world. So I had to kind of like change the bent a little. I mean, and yeah, it's kind of ironic that I'm trying to teach people about not being afraid of nuclear science, and I can't even get them to sign up for the class. So that kind of like, I mean, that's the first hurdle,
Proves
right?
the point, right?
So, yeah, so it landed up being, teaching students in physics about, we start out with the nuclear bomb, like how the nuclear bomb was developed, because as a physicist, it is a amazing scientific achievement. The result is horrendous.
Yeah.
But looking at the speed at which it was built, looking at the money that was spent, looking at how scientists were, I mean, they were giving unlimited resources. And, any scientist is just going to like unlimited resources. Like they didn't have to write proposals. They didn't have to do anything. They just had to ask for it and they got it like that immediately. You're taken to this out of the way place and your whole job is just to solve this one problem. You don't have to worry about anything. That is like a dream for
that is a dream for the scientist.
So that is, kind of where you start out because, it's kind of like this ideological place. But then you have to start talking about, but what was their motivation? And then what is the
impact
product?
of your work? Yeah.
Then what's the impact of your work? So we go to firsthand accounts of the scientists that work there, and what they were feeling. We set the stage for what was America like at the time, because it's definitely not our multiracial, diverse place. I mean, with all its problems, it's definitely not the place that it is now, or even Australia was not the place it is now. The world just was not the place it is now back in the 40s. And then that sets the stage to understand how the U.S. felt it was okay to drop this weapon on Japan.
Yeah.
And then, of course, well, first we talk about all the fire bombings, because firebombing had destroyed Japan in the first place. So, kind of to put it in context. But what the students...
You could see the escalation.
Exactly. What the students really find shocking is we actually, it's this global impacts class. And so we spend some time on the ground in Japan. So I have them read firsthand accounts of the survivors of the bomb. I have them watch movies that were made about the bomb, like Japanese cinema that reflects the time period of, what the general population was feeling, in the decades after, and how they reflected back on the bomb.
Yeah.
Movies that show, the survivors and speaking about their, because it's different when you read it and when you hear someone speaking about it. So I
Yeah.
have them kind of experience what it was like on the ground a little bit, like try to get that point across, because in the US you learn we dropped the bomb, we won the war, and then we move on to something else. Like you don't even give a second thought to after that.
Yes. It's just state fact, move on. No discussion about the consequences or what actually happened afterwards.
Right. But I mean, I think everyone's history is like that. Like whatever country you live in, your history is country centric.
It is.
You just want to tell about all of your glories and none of your bad things.
Atrocities.
Exactly. And
Yeah.
every country has their share of atrocities.
Yeah.
And that's really what the students at the end of the semester, when I ask students, name one thing you're going to take away from this class, and so many of them say that they're going to take away the survivors of Hiroshima and Nagasaki.
Yeah.
Which has always surprised me, because keep in mind we're talking about science students, all these science students who don't understand why we have to take history and don't understand why we have to take literature and all of these gen ed classes. The one thing they take away is something that isn't physics.
And that's the important part. Like
It is.
they need to have that context and they need to understand what they're doing, because when you're presented with that, you're presented with the moral dilemma. There's a meme that went around. It was about have you ever? Oh, I'm gonna have to look it up. But the joke was that as a scientist, have you ever just wanted to break bad and just be evil?
Yes.
Because there's a whole thing where someone throws money at you and says a villain will kidnap you and say build this bomb for me. You could just build a glitter machine. They won't know. They don't understand anyway. But someone else said, yeah, but they're giving you money. When are you ever going to get that kind of grant funding again?
So true.
And so it's that joke, like say you could go evil, but you're not going to. But at the same time, it's the pursuit of science. There's that very fine line between good and evil, and what you're going to use your research for, and what people are going to use your research for.
Exactly.
And you look at a lot of the developments in science and technology, a lot of that was funded by defense.
Yeah.
In various countries. So clearly they had military applications in mind when all of this first began, and it's just grown in scope.
And this is a huge problem right now in computer science, that and I think the field is trying to deal with it. How do you teach students in CS ethics?
Yes.
Because they don't think about, and I mean, they're students, they're 19, 20, they want to build some company, sell it, and be a millionaire before they turn 30. But how do you teach them? Okay, fine, they want to do it, they're okay doing it, but how do you teach them that you probably should think about the applications of your work before you do it?
Yeah.
So you continue and you do it, okay, but have you thought about the implications of that beforehand? And are you okay contributing to that technology? And I know there's a lot of debate and questioning and going around in the US around a lot of things that have happened at Google, and in programs. How do you bring that sort of curriculum into a computer science department? Because
Yes.
you can't rely on this general education to do it for you. You have to have these very specific computer science ethics classes. But then who's going to develop them?
And who's going to develop them, and who's going to take them unless you force them to?
You're going to have to force them to take it. It's going to have to be part of your curriculum. Because they're not going to take them if they don't have to. And to me, that's what that's what, so like your first year common experience in Australia would have worked, I think, if you would have said, okay, you have to take, you know, history of, like your history class is going to be about the history of computation and computer science.
Yeah.
Okay. You'd say, okay, maybe I don't think I need to know it, but at least it's useful. Okay. Or I don't think it's useful, but okay, maybe it's interesting. An ethics class that has to do with computer science. You could take a literature class that has to do with, science fiction, right? So you could
Yeah.
like cover all these topics, but make them interesting to
Yeah.
scientists. Like you can
Exactly. It's not just going to
still,
be a whole think this is how you be good and evil. This is how you decide between good and evil. It's like, well, it's not just that. It's not that simple. It's,
exactly.
there's a lot of gray, and that's the problem. We need to teach about the gray.
And I think part of that is teaching empathy, and that's what I think a lot of these classes I think that's kind of the point of a lot of these gen ed classes, right? If you learn about people and cultures, then you're going to have empathy towards people and cultures.
Yeah.
So I think
It's
that's what
not
they're
so
trying to.
anonymous. Yeah.
Right. And right, like teaching the students about the survivors of Hiroshima and Nagasaki. They actually now know what happened, so they have empathy for what happens to people after the bomb, and then they think, "Oh my God,
Yeah.
if I'm ever in a position, there's no way I would advocate for using a nuclear weapon."
Yeah.
Maybe
And
one of them will be in a position at one point in their lives where, they are in a position to use a nuclear weapon.
yeah. And it's not even just nuclear weapons, like any kind of
Yeah,
technology or science endeavor that we have, because any of it can be used for any kind of purposes.
exactly. And I do this exercise sometimes with my students. I'm like, okay, just name something that you think is good that's been developed. And they tell me something, I'm like, great. And then I give them the bad side to it, and they're like
Oh.
everything they can name me, I can tell them the evil side to it. And they're just like, like airplanes. It's like they deliver bombs, like they delivered the nuclear bomb. That's the bad side to it. And
Yeah.
they're like, oh, like everything.
Yeah. Exactly.
I think the problem is, though, is that nuclear science, the bad side was shown before any of the good sides.
Yeah, and nobody gets to have that perspective because, yeah, it's all about the bomb. It's about nuclear power plants that fail. And, in popular culture, that's what we see. That's what we hear about. Simpsons,
Exactly.
Movies. It's all those, that's all we know about it. So, what else does nuclear science impact in our lives?
Everything. Everything. So, whole podcast about it. So, for example, the the scientists who built the bomb were also the fiercest critics of it, and they actually started all the campaigns to end the bomb and to start a nuclear free world. So they were actually the first kind of human rights advocates against the bomb. So they started all of those movements. When you look at the scientists who have won Nobel Peace Prizes, the majority of them have been physicists. And in fact, they've been nuclear physicists because of their work with the bomb. So yeah, they brought it into the world, but they're also trying to take it out.
Yeah.
So it impacts human rights in that way. But another human right part is nuclear energy. So you mentioned that we see it in the bad light, and that is true because you see it when a nuclear reactor explodes like it did in Chernobyl, or releases gas like it did, or releases the isotopes like it did in Fukushima. But that doesn't count the hundreds of nuclear reactors that are producing energy all over the world at any given time. France has, 90% of their power comes from nuclear, and don't hear anything about them.
Yeah.
I didn't look up how much of Australia's power comes from nuclear energy.
I honestly have no idea, but we are fairly dependent on oil, coal, gas, all the natural resources because I don't even know if we have uranium. in
You do.
Australia. We do?
Sorry.
Mm. Good to know.
But as I was saying about human rights, there are the way that you improve a country's, or I'm sorry, the way that you improve people's lives is by giving them electricity. It's been, I mean, that can't be debated. And how are you going to get electricity to small communities in the middle of nowhere? I mean, people are trying with solar panels. If there's no water around, it's really hard to get sort of hydro, or it's really hard to get
Specific
windmills.
conditions for wind
Yeah,
farms and, all
right.
that. They're all very conditional.
Yeah, all of those are very conditional, but I mean, people are working on these micro reactors that can be put in small villages to give them power. And by, like I said, giving a community power, you then give them access to the world, which you then improve their living conditions. And as far as human rights go, that's one of the human rights that people talk about, is improving people's conditions. And nuclear power does have that ability. So that's one of the ways that nuclear can impact the world. But some of the things that are kind of non-controversial, because I know nuclear power is very controversial. Probably the biggest impact that nuclear science has made, and nuclear science has actually saved more lives than it has taken, regardless of whatever statistic you look at, and that is through nuclear medicine. And we are able to look inside people using MRIs and NMRs, and we're able to diagnose issues, including heart problems and brain issues with those technologies. We're able to use radiopharmaceuticals to see how that we can diagnose different conditions. And then we're able to use radionuclides to treat conditions as well. Not to mention, if you have anyone who's gone through cancer treatment, then of course radiation therapy is a nuclear procedure as well. So all of those things, and then of course PET scans, I mean, all of those things are all nuclear processes. And so many of them were done in research labs before they ever made it to hospitals. In fact, one of the most promising treatments right now for cancer is called proton therapy. And it uses a cyclotron to produce protons. And we've been using cyclotrons to make protons in nuclear physics research for decades. It's just finally been brought into the medical field.
Yeah, and it's all just extensions on existing technology that's been in use.
Exactly. We do a really good job of hiding all the nuclear processes in hospitals because of
the
way,
barrier.
because of the fear that people have. I think it's getting better because there's so many of them now. You just cannot hide it. You cannot hide that you're giving people technetium-99, technetium-99M, you can't hide it. So I think people are getting more and more familiar with it. But at first you had to tell people that an MRI was, it wasn't a nuclear process. I mean, you're not taking a radioisotope, so in that way it's not a nuclear process, but it does use nuclear theory to go about it. And, we were using it in research before it came into the hospital. So that's probably the biggest impact that nuclear has had.
Yeah, and that's incredible. And it's just because of that psychological barrier, it's so hard to be transparent about a lot of these things, because as soon as they hear the word nuclear, those are the first things that they think about. And they don't understand that there's other potential applications for the same science.
Yeah. I mean, there's so many little things that nuclear is involved in. I mean, it's so embedded in our culture in good and bad ways. I mean, the bikini is named because of nuclear physics. Do you know this story?
No.
About the bikini?
Tell me about this. How
does
this work?
The nuclear tests were going on. The nuclear weapons tests in the U.S. were going on in the Pacific atoll of Bikini, the Bikini Atoll, and
Yes.
the Paris fashion designer was just making his new swimsuit, and because of the fanfare going on around the bikini tests, he decided to name his new swimsuit the Bikini.
That's amazing. Purely marketing. That's awesome.
Yep. I think there was something like because it's just as scandalous or something like that.
Oh, wow. Yeah, no publicity is bad publicity.
So I mean, it's stuff like that. It's just it's everywhere.
Yeah.
All the comic books, all the movies. I mean, how many movies are there about nuclear subs? Hunt for Red October,
Yes.
K-29. I mean, there's all these movies. How many movies from the 80s are involved? Who's the bad guy in every 80s movie?
Yes. Well, that was the Cold War stuff. So everything was revolving around nuclear in the Cold War and,
Yeah.
yeah, all the politics around that.
Yep. I mean, that's all nuclear. So, I mean, okay, I'm not really proving my point that nuclear isn't bad because the whole Cold War thing is bad. But the point is that it impacts our lives.
Yeah.
And, it's hard not to see how much it impacts our lives, because if it wasn't for
Yeah.
the nuclear bomb, it's hard to believe we would have had a Cold War. Or because it was definitely that race to outdo the Soviets in different ways.
And all of that, it drives everything else. It drives, yeah, it drives immediately popular culture, it drives the media, it drives literature and art. And because it makes us think all these atrocities and all the ways that it can be used in a bad way is what makes people think and create for the other
Yep.
things, which is why it does impact what we do and who we are.
Yep. It also greatly impacted our space program. I mean, there's questions on how much the US would have invested in the space program if it wasn't for nuclear weapons, because we wanted to get our nuclear weapons on missiles. And what is getting a man to moon? It's just creating a good
A giant
missile.
missile.
So, you can hide all this money that you're spending on, missiles, on this dual use technology in a program that the whole public is for because they want to get a man to the moon.
Yeah.
I mean, it's so sneaky too. Like,
It is. So many different ways. And I mean, props to all of them for thinking about all these novel ways of being able to apply the science.
I know. Yeah, you might be interested in a few weeks. I have a podcast episode coming out on all the different songs around nuclear bombs.
Oh, that's cool. That would be awesome.
So it's like 50 years of nuclear bomb songs. Wow. Like all the different
amazing.
ways, like all the different songs that have been influenced by, and by nuclear bombs and by the protests and by, the fear of it. And then,
Oh, yeah, definitely.
how they've changed over time from, the optimism of the early days to then the Cold War and the fear.
Yes.
You're right. Like, it's something that just, it makes people create because of all the feelings that it brings up.
Yeah.
And, it is a symbol. That mushroom cloud is a symbol that
Yes.
around the world, people know what it means. And people have an opinion, right?
Yes.
I don't think there's anyone that's just like, it's a cloud. Like,
Exactly. No one's indifferent about it. And whether you're old enough to understand or not, it's what's taught to you. And you're taught about the context and the nuance about it. And it's, yeah, whether or not, how close you are to where that became, something that everybody knew about, you're still going to have an opinion. You're still going to have thoughts about what happened.
now I will say what I hope to accomplish is
Yes.
that we should not be as scared about
Yeah.
radiation and radiation exposure as kind of the media plays it up. We're really not in danger of dying from cancer due to radiation exposure that the papers and the media makes you think you are. And that's one of the myths that I'd like to see go away. I can understand people being scared of a nuclear bomb. I'm definitely on that boat. But you're not in danger of getting cancer because you went on a flight or you went to Chernobyl for a few days or things like that. Like those, you need a lot of radiation to get sick or die from it in that way. And I think people are just, I mean, you should have a healthy respect for radiation. Like, I'm not going to go and like lick a source. Like, I'm not going to do that. I'm going to reduce the exposure that I have as much as I possibly can, but
Yes.
I'm not
You can still
scared
go
of it.
about and live your life. Yeah, you
Exactly.
can still go about and do things. And like with most other things, it's just being a bit more aware, a bit more conscientious about how you conduct yourself.
Right.
And yeah, and it's not just like there's radiation everywhere anyway. And it's
No,
not
there
nuclear
is.
radiation. We're surrounded by radiation.
Exactly. And that's kind of the really cool, it's the new thing that we're able to do now in research is there's this new field. Well, it's not that new, but it's called nuclear astrophysics. And have you ever wondered how all the elements in the universe came to be?
Big Bang?
No, turns out.
No.
So the field of nuclear astrophysics sets out to figure this out, to figure out where all the elements and all the isotopes came from. And some of them are from the Big Bang, some of them are from supernova, some of them are from clouds, like, but they're not all from the same place. And there's some that we can't
No.
figure out where they came from. And it's not just where they started, but it's how much did we start with? And then you have to then forward that model to how much we have now.
Yep.
And so, one of your previous guests was saying that, you take in astronomy or astrophysics, you take a snapshot in time and that's all you have, and you have to work around that. And that's the same thing that we do. So when we do an experiment on Earth, we know what that information is here on Earth. And then we have to use our models to try to take that back in time. What we have the advantage of in nuclear physics is that we know half-lives. And so we know how long we can take that back. And so there's a new accelerator being built in the United States that's going to be able to measure more of these very radioactive isotopes, and we're going to be able to try to start solving this puzzle a little bit more.
That's very cool.
So that's really kind of neat. And usually I like problems that have an answer. This one is just a really big puzzle that I don't know when we're ever going to be able to solve it, but it is a nice thought provoking question of kind of where do we come from. And, that's why science is so much fun, is that if you want a very philosophical question to answer, science will give you that, right? You want this thought experiment, science can give you that. If you want a very practical question that you can answer, how do I cure cancer? Science can give you that too.
Yeah, definitely.
And from many different aspects too. Every science can answer that question, how do I cure cancer? Because it takes them all, right? You need chemistry and biology, but you also need physics to help. Someone's got to build you that machine. And it ain't that simple.
It's very, very cool.
Yeah.
So, with the podcast, you've got the full range of kinds of guests talking about the way that, nuclear science impacts us. And it's cool that, you're going to be able to answer some of these questions. for people who aren't already sold on the idea of nuclear science.
Well, I think a lot of people who listen to the podcast are already involved in nuclear in some way, I think. So perhaps I'm also speaking to the choir there too. I'm not sure. We'll see.
We'll find out. But still, yeah, definitely. I mean, anthropologically speaking, super interesting because, yeah, as we've discussed, a lot of impact, a lot of areas that are touched. And yeah, it's very cool. I am enjoying hearing the clips that I've listened to. Haven't been able to listen to all of it.
I know it's hard to listen to a whole bunch of things at once. I've got a lot of stuff queued on my podcast as well. But the podcast kind of goes about what I wanted to do with my class in the first place, which was inform a general audience about things that I love and about how nuclear science connects with the world. And it's a great excuse for me to contact people that can answer all the questions I've ever had and talk to them. And so, I mean, that's kind of the best part about it, is that I'm learning along with my audience. And I have like years of questions that students have asked me that I haven't been able to answer, that now I get to ask the experts, which...
That's amazing.
Makes it sound like I have all these really great questions, and some of them are mine, but so many of them are just questions students ask that I'm like, well, I don't really know that. And so now the expert comes on and I'm like, well, I have this great question.
Very astute.
Yes. But it's just a great excuse for me to learn more, which, as scientists, we're always wanting to learn more and to continue our education in different ways. And I like bringing people along with me and helping them learn about different stuff too.
Definitely, yeah, because there's just so much that we don't know. And there's so many interesting things that you hear about and you go, they didn't go into any detail on that. I would like to know more about what they just said.
Yeah, and we have these medium now, right? Podcast and YouTube allows us, just normal people, to explore these areas of interest to us and then share them with the world. And I think that's great. And to me, the good thing that's come out of COVID is this ability. So if it wasn't for COVID and being locked in, I would have never started my podcast.
Yeah.
Because, people are locked in their house and they're bored and they're not traveling. And it's really, I don't know how many of these experts I would have been able to get on the podcast if they were,
if they also weren't trapped.
Yeah, honestly, because we all have these crazy schedules, and I haven't been anywhere outside of my house for over a year now. And I'm sure a lot of other people are the same way. And yeah, I don't know how many experts I would have been able to find if we were all traveling. And I certainly wouldn't have had the motivation to do it if I wasn't locked in. Because I would have been traveling, and then, for every week you travel, you have like 3 weeks of work to catch up on. So I never would have had the time.
Yeah, definitely. It's just a great opportunity. It presented itself at an annoying time.
Yeah.
Okay, so we'll move on to some of those soft questions so I can get going and enjoy the rest of the evening. Okay, so what hobby or interest do you have that is most unrelated to your field of work?
So this one's hard because most of my interests are related to my field of work. I do love to travel, but that's mostly work. And when I do travel for fun, I travel to places that are interesting to work. Like I went to Chernobyl, which is related to work. The last place I traveled that wasn't for work, I visited some family in Poland, so that was fun. But related to that, when I travel, I do like to go shopping. And that has made me start a shoe. I like shoes, so I guess that's a hobby. I buy shoes.
Yes,
and
that's a hobby.
I actually brought my 2 favorite pairs for you.
Oh, excellent. Show me.
So this is my newest pair.
Oh, very nice. Fleavogs. Yes. Fleavogs are the best.
Oh, I've been eyeing these forever. But in Germany, I found this lovely pair.
Oh, very nice. That's very cool.
Yes. I realize they both
I
have
love
the
that
same
heel.
heel. Yes.
I know. I do like that heel. It's a very stable heel.
It's a stable heel, but it's slightly, different than just a chunk.
Yes.
So
Yep.
these were the shoes I bought in Germany. So I do like shopping for shoes because the Germans have the best shoes, by the way. They're like functional, but they're kind of cool.
Yes.
Yeah, they really have their function and fashion meshed pretty well. So I buy a lot
They
of shoes
really
when I'm in
do.
Germany. Yeah. Um,
Excellent.
but yeah, so that's my most unrelated work hobby.
That's very cool.
Yeah, it costs a lot of money, but I do enjoy it.
It does. Yes. Okay. And which book holds the strongest memories for you? Or which childhood book?
Yeah, this one was hard because I don't really have like a book when I was little that holds the most memories for me, but I have like this series of books. So my mom had a series of the Nancy Drew series of books. I don't so
Nancy
she
Drew's
had
good.
them when she was a kid, and it's like the first books that I remember reading when I was small. And
That's
I
cool.
was really small because I just started reading really young and I read a lot.
Wow.
But I remember reading them when I was really small and I really liked them because it was a puzzle, right?
Yeah.
And I realized, so I said that I wasn't a physicist like growing up, but looking
You're a problem
back,
solver.
exactly. Looking back, I realized I did a lot of physicsy things, but no
Yeah.
one was there to tell me they were physicsy things. So if I had a parent who was a physicist, then I probably would have been told I was doing physicsy things. But, my parents weren't scientists, and they were just like, oh, you're just inquisitive, or, oh, you like to solve problems, or oh, you like to read, or oh, you like taking things apart. Like, that's just or you're good at math. Like, but it wasn't, oh, you're doing engineering physics stuff. It was just, oh, you're
Yeah.
doing it's just
You're just
it's
curious. You're just,
yeah,
yeah.
you're just a curious kid. So it's really interesting how, just because you don't think you were interested in something doesn't mean you weren't. It's just the people didn't point it out to you. They pointed out other things like,
Yeah.
oh, you're good at reading, or oh, you're good at literature. Oh, you should go into this, or oh, you should go into that. Because when I was in high school, I was told I wasn't good in science. I was told I wasn't good in these things. I mean, I actually got a C in high school physics. So, like, it's, yeah, just do whatever the hell you want. Don't let other people, tell you what you're good at.
Yeah. Exactly. And, it's one of those things where you only get exposed to the things that other people have had exposure to.
Yeah.
So you don't know. Like, you don't know what exists out beyond your immediate sphere. Cool. And lastly, what advice would you give someone who would like to do what you do, and what advice should they ignore?
What advice they should ignore? Anyone who tells you you can't do it.
Yeah.
That's it. If
That's it.
someone else has done it, you can do it. You just work hard and ask questions and ask more questions and find a support network. And you can't do it alone, that's for sure. But
Yeah.
ignore them and then look back and feel, superior that they were wrong.
Got to get that gratification out of it.
You do. And I mean, if that gives you motivation, then use it, right? Like, okay, that person told me I couldn't do it and I just want to do it to prove them wrong, then that's fine too.
Spite is a good motivator.
I've used it. I've used spite. It does work. What they should do, they should do what makes them happy and not, well, this goes back to not what they should do, and not let other people influence that decision. For example, when you go into a PhD program, there is kind of this push that everyone should be the same, that you're only successful if you are the number one person in this field of research. You're only successful if you land up at the top institution. You are only successful if you are, X, Y, or Z. That is their definition of success. You figure out what your definition of success is, and that's what you aim for. You aim for your definition of success. You aim for your definition of happiness, and that's what will make you happy. That's my advice. Because you can spend your whole life shooting for someone else's definition of success and happiness, and it's not going to make you happy.
And, that's the thing that everyone tells you, like, you want to be the top, you want to be, the one outstanding in your field, but that's not what everybody really wants to do. Some people just want to be able to, achieve in their own way. That's not necessarily going to be, top tier and, $1 million or, it's, there's so many other ways of defining what makes you successful.
And this is something, honestly, that I still struggle with, because I see people that I came up with that are in similar fields to me, in similar topics, and they're the ones that are being asked to give the talks. They're being asked to, do this or do that. And I'm thinking, but that should be me, right? Or that could have been me, or what did I do wrong? Why am I not that person? But I just have to take a breath and remind myself that I looked at taking that path very early on, and I decided for myself that that path was not going to make me happy. I did not like what came with that path. That path came with a lot of stress that I didn't want, and that was not the life I wanted to live. I wanted to live the life that I have. So I have to remind myself that I don't have that, but not look at what I don't have, but look at what I do have. And that's what I wanted. And so that is my definition of success. And because of that, I have been able to do things that I wouldn't be able to do if I had taken that path. Yeah. And, by defining success in my own way, right, I've been able to, do this interdisciplinary work that perhaps is not as prestigious in the scientific community, but I think is important.
Yeah.
And that makes value to happy. You. Exactly.
Yeah.
And so again, by defining that as my version of success and what makes me happy, then, again, I'm having fun. I think that's my version of success, my version of happiness. And so that is my biggest advice, and that is my best advice. Well, and continue to do it until it's not fun. Definitely. Yes. But also, just even if you have to write it down, figure out what success is to you and stick with it.
Yeah.
And of course, find a group of people that you can talk to, that you can complain to, that you can ask support from, that you can be honest with, because you need that at every stage of your life. You need mentors. You need to mentor people. You need that network of people. So I guess there's 3 bits of advice.
Definitely. And, it's because we're raised in such a competitive environment for most of us, it's really hard to not see other people who, your contemporaries and go, well, they're more successful than I am, or they've achieved more than I have, or they're further ahead in their plan than I am. And, it's about, taking that perspective and understanding that, well, they took a different path to you.
Mm-hmm.
They have a different specialization. They have different passions that drove them down that path, and they were clearly not yours. And
Right.
that is okay.
Yeah, and the problem is that the indicators of success are things that perhaps you aren't your indicators of success, and that's the problem. Right? In the scientific community, it's how many times have you been referenced? How many papers have you published? How many talks have you given? But,
Yes.
if you're not at that sort of institution, then you're not going to be successful by those metrics. So change the metrics.
Yes. Because, you're not going to be in a field where, you're going to be churning out papers,
No.
dozens of papers a year. You're not going to be looking at, you're not going to be in the circles where this is the environment where you can be successful in that way. And, that's normal. That's fine. And it's also like, as you were coming up through your studies, it was, well, this is a thing that I enjoy. I'm also going to have to do things I don't enjoy to get there.
Yep.
And that's another thing I think that a lot of people forget. Like, you measure success by being happy at what you do for every aspect. It's like, no, not necessarily. There are going to be things that you like less.
Yes.
To be able to do the things that you like more.
Exactly. It's like, are you willing to put up... the question is, are you willing to put up with the things you dislike to do the thing you like? And if it's a balance.
It is.
Because no job is perfect. You're not going to love every single aspect of your job every second of the day. But, do the pros outweigh the cons?
Yeah. And it's, you keep hearing about a lot of people saying, oh, I didn't like this, therefore I quit, even though it was the job that I liked. It's like, well, okay, that's your choice, but, it's a unicorn.
Absolutely. Absolutely. It's a unicorn.
Well, thank you so much, Shelly, for this. This has been such an amazing conversation.
Thank you, Michele. It was so much fun. Yeah, it was a lot of fun.
Yeah, definitely. And just learned so much. And it's nuclear science is everywhere. And
it's everywhere.
You really need to take that into account when you're considering all the stuff that we do. It's very cool.
Yeah, thank you. Yeah.
So if people would like to learn more about what you do or reach out, how can they do that?
The easiest way to contact me, I guess, is to go to our webpage for the podcast, which is mynuclearlife.com. And the email address there is mynuclearlife@protonmail.com. That's the easiest way to contact me. And feel free to email me with any questions you have.
Excellent. Thank you so much. And My Nuclear Life, excellent podcast with
you.
so many very cool guests. Very awesome and very educational.
Thanks.
Knowing that there's still foundational science that people are trying to work out is pretty fascinating, and it's also great to hear about the other ways that nuclear science impacts our society. I'm not a big kaiju or Japanese giant monster genre fan, but as part of Shelly's lecture series, I learned that Godzilla was a metaphor for the atomic bomb. If you're interested in that sort of thing, I highly encourage you to look it up, and I'll have a couple of links in the show notes as well. To learn more about Shelly and what we discuss on the show, or to connect with us, please visit the Steampowered website at steampoweredshow.com. You can also reach out to Shelly through her podcast, My Nuclear Life, at mynuclearlife.com. If you enjoyed this conversation, please let me know. Subscribe to this channel, leave a comment below, and share this with your geeky or geek-curious friends. You can also support Steampowered on Patreon and Ko-fi under Steampowered Show, the links for which will also be in the show notes. Thanks for watching!